We're going to switch gears a little bit. It's my pleasure to introduce today's second plenary speaker, Anthony Turton. As president of SIL, the International Society of Limnology, I felt it was important that we foster scientific collaboration and cooperation among scientific societies interested in the same topics. And it's in that spirit that SIL is sponsoring this plenary lecture today. Anthony Turton holds a professorship at the Center for Environmental Management at the Free State University in South Africa, and is also the founding director of the Ecological Engineering Institute of Africa, as well as the co-founder of the South African Water and Energy Forum. He has written extensively on hydropolitics, particularly in the developing world, and he's very interested in the trialogue implicating government, society, and science as a way to manage water resources and even resolve conflict, a topic that I believe he will talk about today. So without further ado, please join me in welcoming Professor Anthony Turton to the stage.
Thank you very much. It's indeed a great pleasure to stand here. It hasn't been easy, believe me. I made a fundamental human error when I went to the airport a few days ago and I looked at my air ticket and I saw 220P and I thought that it was 2200 hours, and it's not. It's 1420. So I missed my flight, and therefore there's been a complicated chain of events. And Isabel, are you around? Thank you very much for your for your guidance and patience in getting me here, but I'm here. So without further ado, let's talk a little bit about my kind of world. I've been listening with a lot of interest to some of the talks earlier today about acidification of the oceans, and something that I don't really know very much about. But I do know a lot about acidification of inland fresh waters, and that's what I'm going to speak about today. So I'm going to talk about this whole concept of the Anthropocene. And that image there, in fact, is not a jellyfish. It's the transition from the Holocene to the Anthropocene. That was when we entered the thermonuclear age. So what's the Anthropocene? My very first introduction to the concept happened a couple of years ago when I was a guest speaker at the Royal Swedish Academy of Sciences, where a colleague of mine was getting a Lifetime Achievement Award, Professor Marlon Falkenmark. I've used a lot of Marlon's work in my own work, and I was a guest speaker. And while I was on the way to the Academy of Science talk, in the vehicle next to me, in the taxi next to me, was a little French fella, and I asked this Frenchman, "What do you do?" And he said, "No, well, he's he works in rivers, etc." And I said, "Oh, that's interesting. What do you So what do you actually do?" And he was telling me about this whole notion of heavy metals and radionuclides at levels of above order of magnitude above background. And suddenly I understood this. Suddenly I had this epiphany, this moment of understanding, because all of the work that I've been doing in the mining belt of South Africa talks exactly about that. So that is my introduction to the Anthropocene. So when I started reading about it, I found it very interesting when Paul Crutzen, who got the Nobel Prize for Chemistry, this is what he said. He said he was at a conference where someone said something about the Holocene. I suddenly thought this was wrong. The world has changed too much. No, we're in the Anthropocene. I just made up the word at the spur of the moment. Everyone was shocked, but it seemed to have stuck. And suddenly all of these things came together, and I do believe that all of the confusion I've had growing up as a young man, all of the different scientific silos that I've been exposed to, all of them are the product of the Holocene, but we're now living in the Anthropocene. So I'm going to expand my argument a bit more. In order to be formally defined as an epoch, geologists must show that it can be recognized in the layers of sedimentary rock in a clearly distinguishable manner. So, we all know about the KT boundary, that's the Cretaceous-Tertiary boundary. That's, as one example, used to date all rocks. This happened 65.5 million years ago when a great big rock came crashing out of the sky, and that resulted in the dinosaur mass extinction. And there you see it in the rocks, all the rocks of the world, all over the world. Just to give you a second example, that's the KT boundary, and it's got a layer of iridium, a radioactive isotope that is unique to that particular event, and you can use it all over the world to measure your date of your age of the rocks. Some say it started 10,000 years ago when Homo sapiens started modifying landscapes for farming and other activities. But more so that happened in the 1800s when the Industrial Revolution started to basically put huge quantities of CO2 into our atmosphere. We've been hearing a lot about the results of CO2 atmospheric pollution. Zalajsevich and his colleagues say it happened in 1945 with the advent of nuclear fusion. So 1945, that is a wow moment. That is an absolute moment in time. This is not a geological epoch. This is a date on a calendar. And there it is. This is one of the first thermonuclear devices that were exploded, Operation Crossroads Baker, in one of the islands in the South Pacific, I think it was. I'm not sure if the island is still there, but certainly it has had a long-term impact. And I knew nothing about any of these things until I was minding my own business on my way to the Royal Swedish Academy of Sciences. And I suddenly came to realize that transitions are typically cataclysmic and sometimes accompanied by mass extinctions. And this is what we're seeing in my part of the world, where there's a substantial ecological, environmental problem playing itself out. And people don't fully understand it. It's a highly politicized event. It's very difficult to work on it for these sorts of reasons. Then I got back to some philosophy. I love philosophy, and I love the philosophy of science, and particularly the philosophy of engineering. And there's a fellow called Rene Descartes, a French philosopher. That's what he looked like. And he came up with this following saying that I always love to quote. I saw that one may reach conclusions of great usefulness in life and discovered a practical philosophy that became the philosophy of what you all practice today, the natural sciences, which would show us the energy and action of fire, air, and stars, the heavens, and all other bodies in our environment, and we could apply them and thus make ourselves masters and owners of nature. So this whole thing about the theme about being master and owner of nature is something that has also been in my head for a long time, because wherever I go, particularly in the mining industry where I work right now, there people are absolutely masters and owners of nature. So let's go back now to the little story I'm going to tell you. This is the city of Johannesburg. This is where I missed my flight yesterday or 2 days ago, but this is what it looked like in 1950. And I told you that the transition happened in approximately 1945 when we learned how to split the atom. But this is what happened just 5 years later. I was born shortly after this. And you'll see that the whole place is just covered in mine dumps. And at that point in time, the city didn't really exist as a city today. The city has grown as a result of mining. But the significance of this particular city is it's the only city in the world that's not on a river, not on a lake, or not on a seafront. It is on a continental watershed divide. It is water scarce. It is arid. It shouldn't be there. So the question is, will the city continue to be there when gold mining comes to an end? And when will gold mining come to an end? And this is where it gets very fascinating. Because within those mine tailings dams and sand dumps that litter the city of Johannesburg, there's a staggering 600 kilotons of uranium. Depending on which mine horizon, which reef horizon was mined, between 10 and 100 tons of uranium was removed for every ton of gold removed. And for the majority of the life of gold mining in South Africa, uranium had no commercial value. So it was simply discarded into dumps. So you now have a metal that was laid down in a geological timescale before atmospheric oxygen existed. We've now gone down 3 kilometers underground, 3,000 meters underground, because of our human ingenuity, because we know how to split the atom, and we know how to do clever things with energy and machinery. And we've now exposed this stuff to atmospheric oxygen, and we expect that it's all going to be okay, that nothing's going to happen tomorrow. And this is a classic manifestation, in my view anyhow, of the Anthropocene that is characterized by heavy metal mobilization by orders of magnitude faster than previous Holocene conditions. And it was this moment, this was the bingo moment that I had when I was in Stockholm. That is a map drawn up by some colleagues of mine. That's a map of the continental, well, that's the, if I get it right here, that there is the Witwatersrand continental watershed divide. That there is the Limpopo River Basin that drains into the Indian Ocean. That's the Orange River Basin that drains into the Atlantic River Ocean, so, the Atlantic Ocean. So we're talking here about the absolute continental watershed divide. It was called the Witwatersrand, which in my language means the ridge of white waters. And it's that name is derived from the fact that there's a massive dolomitic aquifer system under the surface, and that aquifer system has given rise to hundreds of little streams, small little rivers that constantly flowed across these rocks and gave this sort of impression of white waters, the reflection of the morning sun on these little hills, not really mountains, little hills gave the impression of the glistening white waters. So that's the radiometric map, and that's where I work at the moment there. That whole area geologically is divided into 4 different basins. It's all used to be one geological structure that was thrown up as a result of an impact of a meteor impact with Earth, known as in the Vredefort Dome area, that pushed all of this rock strata up to Earth, gave a whole lot of tectonic pushes and shoves, and in subsequent geological events, that entire formation that was now exposed to the surface became fractured as a result of faulting, and there's a big fault that goes through there, and I work just on the one side of that particular fault line there. So these are radiological hotspots that now litter the landscape of the area around Johannesburg, called Gauteng. Gauteng is, in the local indigenous language, means the place of gold. This is a silent witness to this transition, this Holocene Anthropocene transition. That's the highest point in the area. That's the particular water tower that I work in. That is the headwaters of the Limpopo and the Orange River Basin. These are highly modified river systems. And in fact, it was quite interesting when I walked from the hotel to here to see the local little river here. It's also contained in engineered structures, very much like many of the river systems in my part of the world as well. But this is some of the work that's been done now on the radiological risk, and in fact I work at that particular site. This is one of the big mine dumps. This is one of the only mine dumps that actually straddles the divide. Most of the mine dumps, although they're on the continental watershed divide, are in fact mostly on the Orange River Basin side. This particular one straddles the two. And if you look at that radiological map, it's quite interesting, because there you'll see, for example, in this particular context, there's 100,000 tons of uranium in the tailings dams around the Wonderfontein-Spruit, which is a little river. Wonderfontein, the name is also significant. It refers to a miracle. Wonderwerk is a miracle. So the miracle fountain spring, that's what it was called, the little stream with a miracle fountain, because it was this dolomitic structure where water would pop up out of the ground over a dolerite dike and then get a bubble on the surface and go underground and percolate on until it reaches the next geological structure where it would pop to surface again. I mentioned the number 600,000 tons of uranium in the total surface tailings around the Johannesburg area, and I am of the personal opinion, and I don't know if I hope I'm wrong, but I haven't found any data to refute this, that Johannesburg is probably the most uranium-contaminated city in the world. And if what I'm saying is correct, and I hope I'm wrong, then we will increasingly hear more and more about Johannesburg being the most uranium-contaminated city in the world. Human risk is high, but it's consistently denied. It's very difficult to work on this topic. In fact, it's impossible to work on the topic. You will get no funding. It is something that people just don't want to talk about. It's almost like having a strange relative in your family that no one wants to talk about. Impact on aquatic ecosystems is not yet fully understood. In fact, are there any South Africans here? I'll be surprised if there are. There might be one or two, but it's quite interesting that the whole discipline of limnology is not very well established in my part of the world, and I ask why. And it's to do with the fact that funding is not necessarily given. I tried to launch a project called the Tooth Fairy Project, which is based on the St. Louis Baby Tooth Survey, conducted in the United States when the Americans started with their nuclear experimentation, etc. And this particular project was canned. It never saw the light of day. And in fact, it became a career-altering move for me. At that point in time, I was a fellow at the National Council for Scientific Industrial Research, and that's just another story. If you Google my name, you'll see all the sad, sorry saga about that time. But nonetheless, that's an interesting little river basin. That's what I work on at the moment now. There you'll see this plume that's coming out, and I'll show you more detail of this particular plume. This is the decant from the western basin of the Witwatersrand goldfields, and I'll tell you a bit more about that. There's my office right there, ground zero, if you like, in this particular radiologically altered landscape. This is some of the radiological pollution. I'm not going to go into all the maps, but basically these are the maps of around the Johannesburg area. And through persistent work, in fact, after the little drama that saw my career come to an end, became very, very high profile in the media, got a huge amount of public support from this thing, and subsequent to that, government has put a little bit of money into doing some of these things. You'll notice that the maps are all of a very, very low quality. You can't really, the resolution is very, very bad. You can't expand them up to, to get any detail of it, but nonetheless, through a lot of dogged work, there are attempts now being made. But the bottom line is that the landscape we live in certainly around Johannesburg, is closely associated with both the legacy of apartheid and with the mining, and it's highly radiologically contaminated. And it's as I said, a sensitive subject, and in fact this whole issue of criminal negligence remains persistent. As a scientist, I believe that science has got a moral conscience, and I very strongly and firmly believe in the moral conscience of science, and as long as I've got breath in my body, I will not stop talking about this subject, even if I bore some people, and I apologize them for that. But it's important that we understand that ultimately, if you as a scientist know something about something and fail to do something about it, there's actually a very, very important moral application to that. And this is a cartoon that came out of in one of our national newspapers shortly after I was due to give a keynote address at a big science conference in South Africa called Science Real and Relevant, where we were supposed to make our science relevant to what is happening in the country at that point in time. And I was basically served a banning order, and one of the cartoonists in this national newspaper decided to put this little thing out for me. So that kind of made me a bit of a public figure, which is very difficult for me, because from being a scientist working on these scientific things and now suddenly engaging with the media on a daily basis was a tremendous amount of change that I had to undergo in a short space of time. But the lesson from this is that personal risk to scientists working on evidence-based policy reform is extremely high in my country. And this is an important thing. This is one of the reasons why I'd like to reach out here. And this is why I like this whole idea of a north-south, north meets south, because I think it's really important that we get this scientific understanding going across these divides. This is some work that's been done by the Council for Geosciences on uranium. I mentioned earlier on that for every ton of gold, between 10 and 100 tons of uranium was mined, depending on the reef horizon. And this is the map of the Johannesburg area. So that's Johannesburg, downtown city, Johannesburg. That's the sort of conurbation. That's known as the East Rand. That's known as the West Rand. That's where my office is there. I work in that particular area there. You'll see it's one of the most contaminated in terms of uranium. In fact, one of the during the years of comprehensive economic sanctions against South Africa, they were exporting uranium for use in various projects internationally in basic contravention of this embargo. But nonetheless, if you look down there, that's one of the rivers. That's the little Uraniferous spruit I was telling you about. There's a big wetland at the end of that system there, and as we would expect, there's a big concentration of all sorts of heavy metals in it there. Over here, there's a big area of dolomite that underlies that area there, and there's some dolomite in that area there. So the West Rand is heavily contaminated. In fact, the town that I come from, Krugersdorp, used to be known as Uranium City, and there are many other heavy metals that go with it. That's the water tower I was telling you about. If any of you happen to watch soccer and happen to watch the Soccer World Cup when it was in South Africa, the Soccer World Cup took place, the final took place there in a big stadium just about there, okay? So it's right surrounded by 3 of these mega dumps that are now highly contaminated. This is another view of U238, and I draw your attention to that particular river, that little particular system over there. That's ground zero. That's at the moment where there's active decant, and when I say active decant, mining has come to an end, so the void is flooded. There's no more pumping out of the void, and you've now got a void that is vast in size, that is now flowing to surface. In the pre-mining hydrology is now being restored, but of course it's highly modified because the reefs have been eaten out like a Swiss cheese, and you now get this flow of highly acidic water. And it's interesting watching the ocean people talking about pHs of 8, 8 8, and it's becoming acidic when its pHs of 7. Here I'm talking about pHs of 3 to maybe down to 1.8. The lowest pH I've ever recorded were 1.8. But typically pHs of 3, so highly acidic environment, and of course anything below a pH of 5 dissolves uranium. So with a high uranium content, you now get literally liquid uranium coming out of the ground. So that's ground zero. That's what it looked like. That's a shaft called 18 Winds. It's an old ventilation shaft. Shortly after water came to the surface in 2002, when this became a public incident, that particular old fan was taken away. But that's what it looked like. I managed to photograph it before the authorities could take it away, because it became a bit of an iconic image. And you'll see there water basically bubbling out of the shaft. The shaft goes down there. You see all the sulfate buildup over here. You're talking about sulfate contents of about 3,500 parts per million, and virtually everything in the periodic table, if it can be dissolved by acid, it will be. It's in that water. So it's highly, highly contaminated water. And that's my office over there in the background, just to show you sort of where I work relative to the rest. Arsenic levels as well. You'll see that there's a correlation. High levels of arsenic also in the Western Basin. That's the water tower that I'm talking about. That's that wetland I was telling you about there, where interestingly in that wetland they're finding all sorts of animals that are basically extinct animals. They found all sorts of, not quite fossilized remains, but kind of mummified remains of various animals that existed some time ago. This is work done by my team on the whole risk issue. We were commissioned to develop a risk profile for infrastructure. Each of those white lines is basically a main water pipeline that feeds what is essentially the financial capital of Africa, you can call it. Remember, it's on a continental watershed divide, so it's not supposed to be there. So you've got to pump huge amounts of water uphill to keep the economy going. And that's the area that I'm referring to now. That's the Western Basin. That's where decant happened in 2002. The Eastern Basin is that area there where decant is scheduled for about 3 years in the future. That's the Central Basin under the city of Johannesburg itself, where decant is scheduled for about 2005. 5 years into the future. And the far Western Basin is the only area where there's still some decent mining taking place, and that's probably got another 20 years life of mining in it. The rest of the place, in fact, the mining is over. But the important thing is that entire area there now has basically been wiped out ecologically because of the lateral movement, the rapid lateral movement of highly contaminated water in the groundwater aquifer system. And what is very significant, okay, that's my office there, but there's a well field there, one of the oldest well fields that was first built when the city of Johannesburg first started as a mining town. And you'll see that there's actually a drawdown of this contaminated water into that well field, and as a result of this work, they've stopped pumping from that particular well field. But this taught us a whole lot of stuff about the science of acidic water, of acid mine drainage, and we came to the conclusion that it's not about the acid inside the pipe, it's about the acid outside the pipe, and what the acid flow does in your pipe to the outside of your pipeline, and that's an engineering problem that's not really relevant to this discussion here. But this is quite interesting from I guess, from your perspective. This is manganese and iron oxide. That happens very rapidly. It's mineralization that happens very rapidly in that area. You'll see that's a stalk of grass, or it's an old bit of vegetation, a plant or something like that, a branch of a tree or something like that. And where it's in contact with this acidified ground, those crystals start growing very rapidly, and they grow so rapidly that basically there's no time for the material in the middle to decay. So basically it mummifies it almost instantly. Looks like coral. But yeah, so this just tells you how fast it is and how widespread it is. This is a photograph I took just last week at 18 Wind Shaft, what remains of 18 Wind Shaft. This is literally after about a month's worth of flow of water. That's the mineral deposits taking place actively as we speak, and we go back to this idea of this transition from the Holocene to the Anthropocene. I believe that this is that little thin line that you're going to see ultimately in the sedimentary rocks of the future. Whether I'm correct or not is another story, but that's the kind of formations that are taking place, rapid mineralization. This is in a river approximately a kilometer downstream from the decant point, and once again you see this rapid mineralization. But the important thing is that the benthic zones are completely wiped out. They all encrusted with this material now, and the biological activity, I don't know, we haven't really done enough science on it to see what the biological activity is, but indications are certainly using the current scoring systems that we use for measuring organisms. It is essentially a dead zone. What is interesting, there's a little lake here, a little man-made lake, and that man-made lake has got 2 hippopotamus in it, and these 2 hippos have managed to survive this highly acidic water. But what's also interesting is there's a lot of other wild animals in the area. This is actually a game park. And what's fascinating about those animals is that there's been a tremendous amount of spontaneous abortion amongst, for example, springbuck and your various antelope species. And indications are that the presence of uranium prevents the uterus from, you get loss of elasticity in the muscle of the uterus. And this basically means that the uterus can't expand when the fetus is growing, and therefore you get spontaneous abortion. And it's unknown what the impact of this, of course, is on human health, because that's the big taboo subject. That's what you can't mention. It's one of the landscapes about a kilometer from our office, and that's right on the continental watershed divide. And this is a source of persistent radionuclide contamination into highly altered terrestrial landscapes and aquatic ecosystems. And what's fascinating here is that as your mining companies are going out of business, those dumps that have to be maintained are no longer maintained, and those dumps are all in an artificial shape, an unnatural shape, if you like. And they all contain high levels of metals, as I've explained, but they happen to be fairly alkaline. They originally deposited as alkaline at about a pH about 10.5, in fact. But over time, they acidify with acid rain. Acid rain falls on the surface, and this starts mobilizing the uranium. You get a concentration of uranium in the crust. That uranium then, when it dries out next time, that uranium is then blown away as dust, and that now goes over large plumes. And of course, there's very little work that's been done on the implications of this as it enters your terrestrial and aquatic ecosystems. This is a lake. This is actually one of the early phases of this acid mine drainage problem in South Africa. This was taken around about early 2000s when acid mine drainage was first becoming a noticeable problem in the country. This is in a coal mining area, and that is a buffalo that's lying in the water, and you'll notice that there's a blue-green algae bloom in the foreground. And what was initially discovered was that this cyanobacterial bloom actually arose from attempts to rectify the acid mine drainage coming out of the coal mining industry, which taught us that it's not just a simple case of chemistry that if you've got an acid, you put a base in it and you neutralize these two things. There's a whole lot of other things that happen in the process. So it tells us actually that's quite complicated. And for those of you working in microcystin, I'm not a microcystin expert, but this comes from a colleague of mine at the CSIR. Look at the microcystin benchmarks. Finland, 10 micrograms per liter. USA, 60 micrograms per liter. South Africa, 10,000, peaking out at 18,000 micrograms per liter. And frankly, no one gives a damn. So the biochemistry of microsystem was described by a colleague of mine, in fact, one of my mentors, a guy called Fritz Carlson, who did his PhD on snake chemistry, snake venom. And he was working on a project, and he's the guy that actually isolated this molecule and said, that molecule looks remarkably similar to cobra venom, and he knew a lot about cobra venom. So these are some of the problems that we're dealing with. This is a looming national crisis of note. I believe approximately 1/3 of our national drinking water is contaminated in this way. 1/3 of our national drinking water is contaminated in this way, and there is no significant work being done on it. So what are the issues that arise from this? I believe that you've got accelerated rate of change to biophysical drivers. Things are happening very, very fast. And they're happening in such a way that there's an increase in complexity, and there's a generally inadequate evidence-based policy reform to keep pace with the accelerating rate of change. And I think that's kind of really the message I bring here today. The core message, I think, is that when I was growing up, I was taught by very, very clever professors who all came from the Holocene. And they were all based on their entire work on reductionist physics, Newtonian reductionism, which is fantastic. All of you, I'm sure, are experts in Newtonian reductionism. And that's great stuff. But I think the new world we're going into is no longer capable of being dealt with in a reductionist way. I think we have to start learning how to integrate things. Now, it's a bit arrogant of me to stand on stage and say this, but I say this with humbleness in my heart. And I do believe that the future is going to be a time which is upon us right now where we're going to have to learn how to integrate across disciplines and particularly integrate the hard empirical sciences with policy making, evidence-based policy reform. I think this is something of great significance. And the interconnectedness of previously separate systems, you know, in your disciplines, you know, you look at aquatic systems basically as ocean systems or as freshwater systems, and that's the big divide, I guess. But these things are increasingly going to become interconnected, in my view. And I think we're actually looking at an inappropriate model right now with the training of scientists, engineers, and technologists based on this holocenic reductionism. I think we need to start really breaking down the silos, reaching out across disciplines. I know that for some it's considered a bad career move if you publish in a transdisciplinary type of way too early in your career. It's, you know, it's considered as something that where you're watering down or you're diluting the essence of your science. I think we have to look at that maybe in a better way and start encouraging that more. So my humble conclusion is that Newtonian physics based on reductionist logic and specialization is really important. It's great stuff. It's taking us to where we are today. But I think we now need to start thinking more in terms of integrationist logic and transdisciplinarity and how we reach out across those transdisciplinary lines. This, I think, is one of the big issues. Okay, I'm going to start wrapping up. This comes from a book that I wrote. A colleague of mine presented some data on hominid evolution over the last 7 million years, and I found it fascinating. So this is 7 million years in our recent history, and there at the bottom, there's Homo sapiens. Homo sapiens. Just look at how long we've been around. Just look at how long the other guys came, and every one of them that came, they also went. Okay, they didn't last. So the question is, are we going to come and stay, or are we going to come and go? I don't know. If you look at the evolution of the planet and you put it down to a 24-hour time clock and you transpose onto that the emergence of Homo sapiens as a species, we emerged a few seconds before midnight. So this is, I think, the essence of the message. So I say to you by wrapping up, floating in this lifeless infinity of outer space is one blue planet, the only planet in the world that's got water in solid, liquid, and vapor forms. The only planet in the world that's got biological life as we know it. In essence, the Anthropocene, which I believe we now are in, means that Homo sapiens as a species is playing God. But do we have the wisdom to do that properly? And that's I guess, a philosophical question I'd pose. So the take-home message is just because we can do something, e.g. like split the atom, doesn't mean to say that we should do it. And when we collectively learn that lesson, I think that Homo sapiens will truly become a wise man. I say this in humbleness. My name is Anthony Turton, and I consider myself but a child of the Anthropocene. Thank you very much.
Well, thank you, Anthony. I think we need to go to lunch, so we're going to forego the questions, but I encourage you to come and speak to the plenary speakers at the meeting while they're here. And I thank them all for their very inspiring talks this morning. Thank you.